Unit 6, day 1, and I said it and I'll say it again. Factoring is the most important thing you will learn in Algebra 1. It's the number 1 most important thing that you will learn in Algebra 1. We say it again. Is this important? Yes, it's very important. Okay, it's also my favorite, but it really is important. All right, so we are going to factor polynomials in Unit 6. All right, now factoring is basically the opposite of multiplication for polynomials. We don't really divide polynomials, we factor polynomials. And when you factor something, that means you break it down into what multiplies to get that polynomial. Okay, so factoring is breaking down to see what multiplied to get the original problem. All right, so when we factor 12a squared plus 16a, that's a binomial, we are going to break it down to see what multiplied to get that binomial. Okay, so the way we're going to do this today is by looking for the greatest common factor. Okay, we want the greatest common factor that goes between these two terms. All right, so we talked about greatest common factor a little bit yesterday. For numbers, it's the largest number that goes into the two numbers, or however many you got. For the variables, if they have the variable in common, it's the smallest one. Okay? So 12a squared plus 16a. What is the largest number that goes into 12 and 16? 4. So you're going to write down a 4 outside. Yep. I'm sorry, I'm froze. So you're going to write a 4. And then what do both terms have an A? What is the smallest? A. So you're going to write down 4A. So that is the GCF, right? So we are basically factoring out the GCF. Now the rest of it is going to be like reverse distributive property. So I'm going to see what multiplied times 4A to get 12A squared plus 16A. So you're unmultiplying this, okay? It's reverse multiplication. It's actually reverse distributive property. So what times 4 makes 12? 3. 3. So write down 3 in the parentheses. Now what multiplies times A to get A squared? A, right? Okay, another way to think of it is this one has 2 A's. I have 1 A. How many A's do I need again? 1. Yeah, 2 minus 1 is 1. Does that make sense? Because A times A is A squared. All right? Plus, what times 4 makes 16? 4. And I have the same amount of A's already, right? So I don't need any more A's after the 4. And you close your parentheses. So this is in factored form. Yeah. No, because that will get you back to that. So factoring is the reverse of multiplying. You're going to want to say what multiplies to get that original polynomial. Now you can check it distributing in your head. It's 4a times 3a, 12a squared. Don't even look up here. It's 4a times 4, 16a. Yes, so it works out. Now, you got to make sure that the GCF is right here, that this is the largest number that goes into both, and the smallest variable that goes into both. Okay, so you got to get your GCF right or nothing's going to be right. And then you're just basically reverse distributing. Okay, let's try number 2. 15x plus 25x squared. All right, the first thing we want to do to factor is find the GCF. What's the greatest common factor between 15 and 25? 5. And do both terms have an x? What's the smallest? X. And then your parentheses. So any questions about how we got the GCF? Okay, so what times 5 makes 15? 3. Do I need any more x's for that term? No, if it's the same amount, you just go on. Plus what times 5 makes 25? And does that one need any more x's? I need one more x to make an x squared. Is that okay? And then we check it. You can just check it in your brain. It's 5x times 3, 15x. It's 5x times 5x, 25x squared. Yeah, yes. I see why this is my favorite. So we're unmultiplying. Yeah, you gotta know times tables, and you gotta know your exponent rules because you're doing the opposite of multiplying your exponents, right? Yeah, like yeah. You're good. All right, number 3. What's the GCF between 4x and 24? 4. Is there gonna be an x in my GCF? No, why not? Yeah, they both don't have the x, so it's not in common. So we don't include it in the greatest common factor if it's not in common to both. Okay, so 4 is the GCF. So your parentheses. What multiplies times 4 to get 4x? You can put 1x, but it's just going to be x, right? And what times 4 is 24? 6. And if I distribute it, do I get 4x plus 24? Yeah. Yeah. All right, number 4. 20x cubed minus 10x. What do y'all think is our GCF? The largest number it goes into 20 and 10 is 10. Yeah, always see if your smaller number goes into your larger number, and if it does, then that's your GCF automatically. And do they both have an x? What's the smallest x? X. So any questions about 10x being the GCF? So parentheses, what times 10x is 20x to the third? I need 2, and I need 2 x's, right? Because 1 plus 2 is 3. Are you with me? All right, minus. Oops. What do you think? We don't even need. No, you don't need. So what multiply? So basically, what times 10x do I need to multiply with it to get negative 10x? Negative 1. Negative 1. Yeah. So you can't just leave it empty. You got to have at least 1, right? And then you can check it distributing. Is 10x times 2x squared 20x cubed? Yes. And it's 10x times negative 1 negative 10x. Yeah. Yeah. So be careful with your signs as well. You can clearly see that. Oh, don't ruin the fun for me. Fun for her. I'm telling you, it's my favorite. All right, this one's got a few more variables in it. 45x squared y minus 20x squared y cubed. So 45 and 20. What's the largest number that goes into both 45 and 20? Y'all agree? It is 5. Does every term have an x? What's the smallest? X squared. Does every term have a y? What's the smallest? Y. Parentheses. Is everybody okay with the GCF? I'm telling you, if we can't get GCF right, nothing's going to be right. Okay, so we got to make sure we're good with GCF. Now, what times 5 multiplies times 5 to get 45? 9. Does that term need any more variables? No, I've got x squared y in my GCF, and that term has x squared y. The variables are the same, so you just move on. Okay? I'm going to copy the minus. What times 5 is 20? 4. Does that term need any more variables? Yes. What does it need? It's got the same x's, but it needs 3 y's, and I only got 1 y, so I need how many more y's? 2 more y's. So y squared. Does that make sense? Y'all see how I'm doing that? Basically subtracting what you need from what you got. Okay? And then we can check it. It's 5x squared y times 9, 45x squared y. Yep. And is 5x squared y times negative 4y squared negative 20x squared y to the third. Yep. You add those y's and multiply the numbers. All right. What kind of polynomial is 16? Trinomial, because it has how many terms? 3 terms. Okay? You can still do GCF with a trinomial. Y'all got that copied? 18CD squared plus 12C squared D plus 9CD. Now, 18, 12, and 9. What's the largest number that goes into all 3 of those? Y'all agree it's 3? Okay. Do all 3 terms have a C? What's the smallest one? Do all three terms have a D?
Yes.
What's the smallest one? Good. So is everybody okay with 3CD being the GCF? That's a lot of letters. Okay. What times 3 is 18? Does that term need any variables? What does it need? It needs a D. Good. Plus, what times 3 is 12? 4. Does that one need any variables? It needs one more C. Is everybody okay with that? Doesn't need any D because it's got the same amount. Plus, what times 3 is 9? 3. Does that one need any variables? No. Close your parentheses. And then you can check it. 3CD times 6D is 18D squared. 3CD times 4C is going to be add your C squared. And 3CD times just 3 is 9CD. There you go. Y'all want you try? Y'all got 3 of them.
This isn't so hard. This isn't too bad. So it's gonna get worse. So
This is the very beginning of the unit. What do you think is going to happen?
we're gonna find out other ways to factor things.
We're going to factor lots of different things.
Added, subtracted, but it's math is stupid.
Not this one. I'm having a ball. Let me know if you get stuck. The GCF is the most important part.
What's that slow?
Just hush and do your work, please. Let me know if you need help. Don't write GCF equals. We didn't have that accurate. That's not true. It's not mathematically correct. Your GCF is what's in front of it automatically. Okay, you're doing GCF, right?
Yep.
So what's the smallest A you got? No.
Okay.
Yep, so write it down. What's the smallest B you got? Yep, B squared. There you go. No, that goes in your GCF.
Oh, okay, so you can have an exponent outside.
Yes. There you go. And then you say, what times 2 is 2? Well, that's 1, so you can leave that off. How many A's do you need?
2.
Yep, so A squared. And then how many B's do you need for the first term?
2.
3, and you have 2.
Oh, 1.
So A squared B. No, not plus. A squared b times together. Alright, now you do plus. Then you're gonna do the middle term. What times 2 is 4. And does that one need any more a's? No, and it doesn't need any b's either. So copy your plus sign. Yeah. Yep. And then how many a's do you need? GCFs. There's one.
And then no.
And no b's. That's right. If y'all finished all 3 of them, check them with somebody, please. Hey, you copied that last one wrong. Yeah, that's supposed to be to the third. So you do need one B on that one.
And then she
We have a lot more time to do. I can factor y'all for a whole other hour. Can we do this? I would like to. Okay, so something I'm noticing is we got to copy the problem, right? Right? Because if you miss one of the legs on a copying, then yeah, that's gonna mess up your GCF and everything else. So be sure that you copy correctly. All right, so number 7, 14x squared minus 21x. What is the GCF? I love how you wait till I get up here and teach and then do that. I'm sure it was running 30 seconds before I got up here and started teaching. All right, 14x squared minus 21x. What is the greatest common factor? 7. What about your variables? Does it have an x in common? Yeah, what's the smallest x? Good. So did y'all get 7x for your GCF for number 7? What times 7 is 14? 2. Does that one need any more x's? Yes. One more x. Y'all okay with that term? Minus, what times 7 is 21? Does that term need any more x's? No. Raise your hand if you got 7x times 2x minus 3. Any questions? All right, number 8 is the binomial, but it's got a lot of variables. Number 8, what is the largest number that goes into both 24 and 36? If you say 6, that's not the GCF. So if you use 4, that's not the GCF. Or 2. Okay, so make sure you get the largest number. All right, so 12 is the GCF for the numbers. Now we're going to do our variables. Does both terms have an m? What is the lowest? They both have an m squared. Do both terms have an n? Yes. What's the lowest? N. Do both terms have a p? So do I put a p in the GCF? No. So 12m squared n is the GCF. Did y'all get the GCF correct? All right, because if we don't, we're going to miss everything else. Now, what times 12 is 24? 2, does that variable need any more m's? Does it need any n's? But it needs a what? It needs a p. Got it? Plus, what times 12 is 36? 3, does that one need m's? Does it need any n's? It needs one more n. Raise your hand if you got that for number 8. Any questions? Number 9 is a trinomial. Same thing, you just got to do it for 3 terms. What is the largest number that goes into 2, 8, and 16? 2 is. Good. Do all 3 terms have an a? What's the lowest a? Do all 3 terms have a b? What's the lowest b? B squared. So 2ab squared is your GCF. Is everybody okay with that? Parentheses. What times 2 is 2? 1, so I'm going to move to my variables. What times a do I need to get a to the third? I need 2 more a's, so a squared. What about b's? I need 1 more b to make that term. Bless you. Plus, what times 2 is 8? What variables do I need for that term? None. I have the exact same amount in my GCF, so move on. Yes. Yes. Plus, what times 2 is 16? 8, does that one need any variables? It needs one more A and one more B. Raise your hand if you got those. Any questions about factoring out a GCF? Because we're going to need it for the next thing. Okay. Okay, so the next thing we're going to learn about factoring is when you have 4 terms. We're going to use something called factor by grouping. So write that down, when you have 4 terms. Exactly 4 terms, not 5, not 3. No.
She said exactly 4 terms. Sorry.
I'm not going to have y'all factor anything in 5 terms unless it has a GCF. Okay, so when we have 4 terms, we're going to do something called factor by grouping. And that's exactly what it sounds like is what you're going to do. You're going to use grouping. Okay? Now, what do we use in math to group things together? What symbols do we use to mathematically group things together? Parentheses, right? So we're going to use parentheses. Have y'all got number 10 copied down? Yes. All right, I'll hush and let you write for like a second. I'm so excited. Factoring is so fun.
Let's start with this one. We got 0, 1. Send us an intermission song. Send us an intermission song.
Okay, so we have 4 terms in this polynomial. Do y'all agree? Okay, and the polynomial is in decreasing order. It doesn't really matter that it is, but I'm just noticing that it does. And they made it easy on us on this first one, and these are all plus signs. So we get some negatives in there, it gets a little bit more complicated. So factoring with 4 terms, we're going to do factor by grouping. And we know that parentheses are famous mathematical grouping symbols. So what you're going to do to factor by grouping is you're going to group with parentheses the first 2 terms together and the last 2 terms together. Group the first 2 terms and the last 2 terms together. Now, after you do that, for just a moment, you're going to ignore the second group. Okay? Ignore that parentheses and look at the first parentheses. And we're going to factor out the GCF of the first parentheses just like we did previously. Okay? So just forget the rest of the polynomial for a second. We're focusing on these first 2 terms. What's the GCF between 4a to the 3rd and 8a squared? 4a squared. Y'all agree? Okay. And then you do it like we just did. What multiplies times 4a squared to get 4a cubed? I need an a. Good. Plus what times 4a squared equals 8a squared? 2 with no variables. Y'all agree? Close your parentheses. Bring down your plus sign. Y'all with me? What is now I'm going to do the second parenthesis, just like I did the first. Okay? What is the GCF between 3a and 6? 3. Do I put a variable in there with it? Not for the GCF, because they both don't have an a. Y'all with me? What times 3 is 3a? A. Plus what times 3 equals 6? And close your parentheses. Do you see something? Just noticing. No, you're not. What do you see? What's the same thing? Exactly. Guess what's supposed to happen in factor by grouping? The parentheses should be the same. Okay? If not, then you either picked a wrong GCF or you unmultiplied something. Okay? So we are ready to write down our answer. Now to write down your answer, it's going to be 2 binomials. Y'all know what a binomial is, right? A two-term, like this a plus 2 is a binomial, right? So your first binomial, and it doesn't matter the order, one of your binomials is what is copied in both parentheses. So a plus 2. So that's one of my binomials. So write that down and look up so you can see what I'm doing. Your second binomial is everything that's in this row right here that is not in a parentheses squished together. So this 4a squared and this plus 3, you're going to make it a binomial together. And those are your two factors, and you are done. Now, if you wanted to check that, you would FOIL it, but we're not going to do that because people get confused going back and forth, so we're not going to do it. Okay? Don't do it. You will get confused. But you can check first term and last term. Last term, just to be a brief checker, it's a times 4a squared, 4a cubed. And it's 2 times 3, 6. Yeah, so we're just saying we got the rest of it right too. All right? So, yeah, so these two binomials, if I FOILed them and multiplied them together, I would get that polynomial. Okay? Y'all with me? So that's what you're doing when you're factoring. When you're factoring, is you're breaking it down into what multiplied to get the original polynomial. Does that make sense? These two things multiplied together get this, but this is the factored answer. We're not going to re-multiply and get to where we started, then we're just going in circles. Got it? When we get the two factors, we're done.
You can go in circles a lot in math.
You can, because you can constantly keep undoing what you just did. All right. Let's do another one. Oh, yeah, you know I got to make it more and more complicated. Can't have it easy all the time. Copy that one down. How many terms does it have?
4.
4. So how are we going to factor with 4 terms? Grouping. Grouping. We might not. Okay. So I'm going to group my first two together. Now this gets a little tricky when there's a minus in the very middle. I personally don't like these as much, but it's okay. We'll get around it. So the first group. Do y'all see a GCF in there?
No.
1. Yeah, 1 for the numbers. What about the variables? Do they have a GCF? X. Okay? So X is the GCF for those two terms. Y'all agree? So parentheses. What times X do I need to multiply to get 2xy? 2y. I need a 2y. Y'all agree? And then what times X do I need to get 7x? Positive 7. So plus 7. So any questions on how we factored the first group? Is that okay with everybody? Now this is a minus in the middle, so we got to be a little bit more careful with our signs. So what is the GCF between 2y and 7?
Negative y.
They both don't have a y, right? And those are both prime numbers, aren't they?
Yes.
So 1 is the GCF. Y'all agree?
Yes.
1 is the only number that goes into both. So I'm going to have this minus 1 out here. Okay? Then we got to think just a little bit. This was a negative 2y. I just stuck my parentheses there, right? What multiplies times negative 1 to get negative 2y? A positive 2y goes there. And then what multiplies times negative 1 to get a negative 7? A plus 7. And there's you a clue. If those little signs confuse you, you know the second parenthesis is supposed to look like the first parenthesis, right? Yeah. Okay. So, and that's true 95% of the time. There's a special circumstance that I'll show you in a little bit. So what are my two binomials then? X minus 1 and 2y plus 7. And it does not matter if I put the 2y plus 7 in front of the x minus 1 or after. Okay? Because multiplication is what we call commutative, meaning you could swap the order. 2 times 4 is the same thing as 4 times 2, right? Okay, so you can swap the order of your two binomials. Just gotta make sure what's inside the binomials is correct. Got it? Any questions on that one? Factor by grouping is easy, isn't it? Number 12. I think y'all have a U-trap on this one. Oh, yeah, you do.
Now, it looks like a stretch, but y'all, it doesn't get skinnier, it gets flatter. So this is gonna be a trend. So in this case, our A value is -1/2.
All right, y'all copy down number 12.
So when we plug this into vertex form, we're gonna have y equals -1/2 times the quantity x plus 3 squared plus 19.
Yeah, I ain't gonna bite your finger off. How many terms is it? 4. How do I factor with 4 terms? Grouping. Group the first. My thing's slid. Group the first 2 and the last 2 with parentheses. What's my GCF in my first group? What about variables? 5x. Y'all okay with that? What multiplies times 5x to get 35x? 7 minus. What times 5x gets negative 5xy? Just y. What's a minus y, isn't it? Ooh. Plus. GCF is what? 3. Parentheses. Y. Minus. Ruh-roh. Why is that a uh-oh?
And it's not community.
And they're not the same, are they? No, 7 minus y is not the same as y minus 7. If these were plus signs, would they be the same? Yep, they're not the same. So we have to mathematically manipulate them to be the same. Right? Mathematical manipulation. Ooh, that's a fun alliteration. I can't either. Okay, so what we do is we write it in a way that keeps the problem mathematically correct. We're not changing the value of it, we're just changing the way it looks. Okay? Because, okay, let's say, okay, let's just put them in the right order. Let me go to the board. Well, video people can't see the board, so I'll do it right here. So 7 minus y. Isn't that the same thing as negative y plus 7? If I put them in decreasing order? Okay, so these definitely have opposite signs than this. Do y'all see that? How do you mathematically change signs? Multiply by what? -1, right? So if I can multiply this first binomial by -1, it would change it to look like this, would it not? Okay, so that's what you do. You just stick a negative on the very front term. Or you can stick a negative on the middle term. I like to stick it on the front. And then change your signs. And then copy the rest. Let's put it in -7. Sorry, guys. And now they're the same. So if there's subtraction problems in an opposite order, you only do that with subtraction because if it was addition, it'd be mathematically the same already. Right? So if there's subtraction and they're out of order, then you just stick a negative on the front and change the first parentheses to look like the back parentheses. Does that make sense? Now they're the same in both parentheses. So what are our two factors? Y minus 7 and -5x plus 3. Okay, so that's all you got to do. So that's a very rare occurrence, but it does happen. And they should still have the same terms in them, just in a different order with subtraction. Okay? Got it? Now, if they're not the same terms at all, then you probably did a GCF wrong, more than likely. You try this one, but it's, 2 of them? Yeah. Y'all try both of those. One of them's normal, one of them's not. That's how we get to know if we can do it or not. It's through practice.
Practice for that.
Okay, now if you're messing with a calculator where you don't know what's going on, you're gonna lose your group. And it's gonna cause everybody
I
else.
said I could have guessed it.
Is that understood? I've already given that one to this class, is that correct? The only thing that we have gone over is we have gone over.
Let me know if you get stuck.
You just type in, add, subtract, multiply, divide, we're talking about exponents, and we're talking about taking square roots, that's all we've done on this screen, yes? We've changed fractions, or decimals, fractions, decimals, stuff like that, and we've gone to the graphing one, we haven't done anything else. So if we haven't done anything else, you're not on anything else on my calculator. You're not typing in inappropriate messages where somebody's finding them and showing them to you.
That's one way to lose your calculator.
That's the case, because I took my phone out and took a picture of the calculator. And if I find out who did it, nobody, that person will not touch another one of my calculators. You have to go by your own.
Some toppings.
Is that understood?
Yes.
You should not be on anything
Top
else.
stuff in my calculator, you will get to use
Is
it.
that understood?
I don't care if it's like test out.
All right, so your table should match these values. All right, so those last two were a little tricky. With quadratic, we really want the vertex involved as much as we can. Okay, so those were a little tricky. So, I apologize for messing up my own paper graph on number 7, but we did fix it. All right, are we okay on these? So I did just want to show you some functions of this graphing calculator. Now, we graph linear functions here, so y'all know if we can graph linear, we can graph quadratic, we can graph exponential, we can graph all that kind of stuff. Yeah. Okay. That doesn't take away the importance of knowing how to graph functions. Okay, so both are really equal. Good deal? All right, any questions on this very short, quick lesson? No?
Yeah. I started it right.
All right, so just 4
We're
problems.
simplifying radicals, do special route triangles.
4, yeah, y'all want more?
30, 60, and 45.
You sure, Jason?
These already have.
You sure for both of them?
Yeah, but at least you're like.
So, sorry, don't make it all that long. I'm done by 6:45. And it don't take you. I mean, I understand that student athletes are what and kids today, student athletes, students first, athletes first. That's all I'm gonna say about that. All right, when I call your name, I'll get the quiz.
Here for his
Audrey. Lex.
testing. I did that. Eighth grade, but.
Yeah, that's. I got 3 counts.
Algebra 2 repeated.
All right, y'all check them with each other. Number 14, I think you had to do a little something special.
It's what?
Immigrant, all right. No, wait, we can go back. Oh, okay. So is it right?
Mm-hmm.
Did the opposite. Where's your paper? Alright, that's yours. Okay. Explain it. We did 7.
Okay, yes, and they're mathematically equivalent. As long as they're the same across three, and 4A minus 1 is the same as that. That's wrong. So they're mathematically equivalent. Just multiply the negative. Yeah, I always take it on the front just so I know that that's where, that I had an opposite sign. Yes, that is mathematically equivalent. Good job. Good job.
You said it's really shut.
Okay, let's finish up the lesson and go over these, please. Number 13. How many terms are in number 13? 4. How do you factor with 4 terms? Grouping. Now, I'm going to keep asking y'all that over and over in this unit. How many terms are there? Because that's an important thing about factoring, because that lets you know what to do. 4 terms we group. 3 terms we do something else we're going to learn about tomorrow. Okay? So, 4 terms we group. So I'm going to group the first 2 and the last 2. What is my GCF in my first group? 5 what? 5y. Y'all agree? Parentheses. What times 5y makes 5y squared? Minus what times 5y is 15y? 3. Close parentheses. Copy the plus. Is everybody okay with that? Then the second group. What's the GCF between 4y and 12? 4. Parentheses. What times 4 is 4y? Minus what times 4 is negative 12? Negative 3. Are they the same in both? Yep. So what are the factors? Does it matter what order? No. As long as you get the right thing. Whoa. Wrong variable. All right. As long as you have the contents correct, you have one that's 5y plus 4 and one that's y minus 3. It doesn't matter the order. So raise your hand if you got number 13 correct. Any questions? All right. Number 14, we had to do our trick too, didn't we? Well, I'm spoiling it. Spoiler alert.
Is there gonna be somebody coming to practice for that?
Yes, maybe. I'll have to look, but maybe. All right. So grouping. What's my GCF in my first group? 3A. Do y'all agree? Parentheses. What multiplies times 3A to get 3A? 1. Copy the minus. What multiplies times 3A to get 12A squared? 4A. Plus in the middle. What's the GCF between 8A and 2? 2. Parentheses. What times 2 is 8A? 4A. And what times 2 is negative 2? Are they the same? No. Can I fix it? How do I fix it? Put the negative in front and then change the first parentheses to match the back one. Okay? And then what are the 2 binomial factors? And yeah. So the outsides go together in one binomial and the insides are the other binomial. Now, you could technically multiply this one by -1 and change that to a -2 and this to a 1 minus 4a. Okay? That's mathematically equivalent. All right? But I like to stick them on the front, so I know if I have a binomial with a negative on the front, I know that I had to switch it. Okay? That's how I like to do it. So raise your hand if you got those 2 binomials or something I told you that was mathematically equivalent. Very good. That is the end of notes for today. We're about to practice. Have a good rest of your day.